Welcome back. I'd like to actually start today's segment by looking at the code that we have discussed in the last video segments and putting it to work and actually looking at how this pans out. So the first thing I'm going to do is go into Emacs and bring this up. So let's bring the table a little closer and get going. So if I go in Emacs and I load this file, tpp print, CPP, we get exactly the code that was on these two slides, right? So if we look at these two slides, that was the base case, if you recall, of my print for the inductive definition of a type-safe version of printing. And the second slide was the inductive case where we have a parameter pack here, and what I'm doing is that I'm peeling off the first argument from the parameter pack with type T, and then I have the subsequent one. And as you can see, the code is definitely here. In this inductive definition, we're doing what we promised. We're looping over the format string. If it's a % character, we're going to do a case analysis. If we're seeing another %, we print it out, right? So we move the format. Otherwise, we're going, in the case of an integer, a string, or a floating point, we're going to do the printout of value. Note that I don't need to do more things here unless I wanted to check that the type I'm given is consistent with the specification character here. It works because value, as you notice, is of type T, and here, therefore, when I send the value into the output stream, the type T is being used, and if it's an integer, I'll get the printout of an integer, right? Then I call recursively my print on the rest of the format string and the rest of the parameter pack, which is my last argument here. So that's the structure of this program. No big surprise. If we look at the main function, which of course is also visible here, so I'll move that slide to the main function. All I'm doing here is saying, hello, are you this many days old? So it's asking a question, and I'm passing a string and an integer. So clearly this is polymorphic. Let's switch over to the shell, compile this. So C++, tpp print, -o tpp print, -std, C++14. So I compile that file. Okay, it's done. So now if I run tpp print, we get the question, hello you, are you 10 days old, right? Which is exactly the behavior we were expecting. So this is working. Notice that last time I pointed out that we are not checking whether the types are consistent here. So how would we do that? Well, thankfully there is a mechanism to actually achieve that result, and it's using another feature of the meta programming. I'm just going to give you a little bit of a sense of it. If you want to find out more, you can go on CPP reference and check the documentation of all these things, but you can check at runtime, or at least at compile time, right? I should not say that. At compile time, you can check the type of an argument, so you can find out what T is and make this conditional based on that. So here, for instance, what I could do is break down my case analysis in 3 cases. And I could say, here, I know that it's a D, so I'm expecting an integer. And there is a way. In the STL, I have std, and then there is a function called isSame, and it takes as an argument 2 types. And the 2 types, of course, this is a template, right? isSame is a template. So what are the 2 types? Well, there is T, right? I want to check what the type T is, and since my format argument character is a D, I know I want an integer. So I can check whether these 2 guys are the same, and exactly like we did in the case of meta programming of factorial, I can pick up a value. So I can find out in the value field of this templated structure, which is parameterized by T and int, I can pick up value, which is a Boolean, as you would expect. And I could say that if it's not a Boolean, so I could say that if this is false, so I negate it. If this is false, I'd like to actually scream, right? And the way we've done the screaming before, we'll do it in the same fashion. It's by throwing a runtime error. So I'm going to pick the runtime error we had over here, and I'm going to put that in this case, and I'm going to raise the error, and I will say invalid format string expecting integer, right? So because that's really what I want. So if there is this problem, I will raise that error. Otherwise, I will go on sequentially to my code here, or to make things even cleaner, I can make my call and have something beautiful. Now, in the two other cases, S and F, I could, of course, do the exact same thing, but I just want to show you the idea of using isSame to find out whether there is a problem. Of course, we probably have to include the right header file, which I don't remember on top of my head. So let's check real quick whether this works out of the box. Probably not. Oh, no, it does actually. So I already include the right header file, apparently. We can check what we're including. I'm including IOStream and STD exception. So it must be one of the very basic things. And now if I run tpp print, it works as expected. But now let's go back and do something horrendous in the main program. Here, you know that the second thing I said will pass an integer, right? That's what the person D here means. And here, therefore, let's pass something wrong, like a string, right? So I pass a string, I expect an integer. What's going to happen? Am I going to have an error here? So now I go back to the shell, I compile again, no compile time error. That's correct, right? If you think about it, if you look again at the code, I am checking here with a test, which is a test that is based on the type t and int, whether it's the right value. But if it's not, I'm raising a runtime error. So at runtime, I will be able to detect whether the type that I have passed in the or the specifier I have passed in my format string and the type of the corresponding argument, I check at runtime whether they match. Remember, printf doesn't do that. It doesn't check anything. Here, this is what I'm going to get out of it. So now that this is done, let's run tpp print, and lo and behold, I have an exception raised, and he's telling me that he's terminating the application because the exception wasn't caught. Okay, that's right. I should have been a little more careful in my main program. I should be saying, let's try to call my print, and let's catch any runtime error. So I can say that const std runtime error cout raised, and let's just hope that an error can print itself on the output stream. I haven't used probably any using std, so let's just do the right thing and tag it. Now I'm catching the error. That should be much better. Let's compile. I've done a mistake. There is something it doesn't like here. Okay, so he doesn't know how to print a runtime error. Now, I don't remember on top of my head how you're getting the string of the string that's embedded inside the error. We could check on the CPP reference page, but for now I will just say raised and not print the message. So you can improve that a little better, but at least now I should be able to compile this. Okay, it compiles. Let's run it. And now he tells me, hello, you are. And once this has been done, he says raised. So clearly he started printing, then he saw that there was an issue, and he raised the exception exactly as our code meant this to happen, right? So I can have, with this little isSame trick, I can do a case analysis in my format string to make sure that whatever is being passed here as an argument, if I say I want an int, I can check, is what I received t an int? If that's the case, everything is okay. If it's not, I'm raising an error, right? And that's a much cleaner way to actually deal with that. So we have a type-safe printf, which is now capable of catching errors in typing at runtime, as well as errors in the number of arguments provided to the variadic template function. And that's all I wanted to show you. Here you get now a sense of how to actually make use of this facility, and you realize that this can be quite beautiful actually. You can get a very simple implementation of print that is completely resilient. So with that, I'm wrapping up this segment of video, and I'll see you next time to look at the next topic.